Welcome everyone. Welcome to the digital communication session. In this today session, we will do line coding techniques. That is lecture 5. That will come under unit 2. Now, what is line coding? In this section, we see how we can represent digital data by using digital signal. Here, we are converting the digital data into digital signals. Now, this is the digital data, that is 0101 binary data. We are converting this digital data into digital signal. This is the representation of the signal. We are converting digital data to digital signal. We assume that the data in the form of text, number, graphicals, images, audio, video or audio are stored in computer memory as a sequence of bits. Now, this data are stored in a computer as a digital bits, that is 101010 form. The line coding converts a sequence of bits to a digital signal. At the receiver, digital data are created by decoding the digital signal. At the receiver end, it will receive the digital signal and recover this digital data. Now, this digital data is 1010. How you are generating this data? By analog to digital converter, by PCM or delta modulation, you are getting this data 1010 form. Now, this data in binary form, we are doing the line coding. We representing this data into digital signal now, or you can say in electrical pulses. Now, some important characteristics of line coding: signal element versus data element. Now, what is signal element? Recall the digital signal is a sequence of discrete discontinuous voltage pulses. Each pulse in digital signal is a सिग्नल एलिमेंट. जो भी हमारी पल्स होगी डिजिटल सिग्नल में वो क्या होगा? सिग्नल एलिमेंट. नाउ दिस बाइनरी डेटा इज ट्रांसमिटेड बाय एनकोडिंग ईच डेटा बिट इनटू सिग्नल एलिमेंट्स. नाउ हियर वी आर ट्रांसमिटिंग दिस 1010 डेटा बाय दिस पल्सेस. नाउ देयर कैन बी वन टू वन correspondence between data elements and signal element or one to multiple to one. In the next slide, you can see the difference between the signal element versus data element. Now, data elements is the number of bits we are doing the line coding for. Now, here you can see we are taking the two data elements 0 and 1. Here we are taking the 4 data elements. We are combining 4 bits together. This is the 4 data elements. This is the 1 data element, 1 data element, 2 data element, 2 data element, 2 data element. Now, what is signal element? Signal element, we providing the voltage to that data element. Here you can see we are using one single signal element. Here we are using 0 and 2. 2 voltage is representing one data element, that is 2 signal element. Now, here you can see we are representing 3 signal element for 4 data elements. Now, what is data rate? Data is the number of bits that is transmitted per second. Signal rate is the number of signal element in 1 second. The unit is baud and the for unit is bits per second for the data rate. Now, data rate sometimes is called the bit rate and signal rate is sometimes called as the pulse rate, modulation rate or baud rate. These are the two important parameters for the digital communication analysis, bit rate and signal rate. We do the comparison of the different digital modulation scheme based on this data rate, signal rate. Now, bit rate is the number of the bits transmitted during the 1 second. Baud rate is same as the signal rate, number of the signal per element per second data required to represent that bit. Now, modulation rate we can also call modulation rate to baud rate. Now, in terms of computers, to measure the efficiency of a computer we use bit rate, and to measure the efficiency of a data communication system we use baud rate. Now see an example. An analog signal carries 4 bits in each signal element. Now here we are given the 4 signal element. If 1000 signal elements are sent per second, find the baud rate and bit rate. Now we have to find out the baud rate and bit rate. Now baud rate, what is baud rate? Is the number of signal elements per second. So how many signal elements are transmitted in 1 second? That is 1000. So baud rate, it will be the 1000 baud. Bit rate, that is the baud rate multiplied number of the bits per signal element. Baud rate हमारा कितना है 1000 मल्टीप्लाई में नंबर ऑफ बिट्स पर सिग्नल एलिमेंट दैट इज 4 इज गिवन 4 बिट्स इन ईच सिग्नल एलिमेंट. एक सिग्नल एलिमेंट में हमारी 4 बिट्स जा रही है तो उसके मल्टीप्लाई कर देंगे, यू विल गेट द बिट रेट दैट इज 4000 बिट्स पर सेकेंड. द सिंपल्स पैरामीटर्स बिट रेट, सिग्नल रेट. Now the basic requirements for line coding, these are the some requirements for the line coding techniques. First is the small transmission bandwidth. It should be having small transmission bandwidth, power efficiency as small as possible for required data rate and probability. Third one is the error detection and correction. Suitable power spectral density is very important parameter. Timing information, clock must be extract from the data. Transparency, all the possible binary sequence can be transmitted. Now line coding further divided into different type of line coding: unipolar, polar, bipolar, multi-level, multi-transition. First we will do the unipolar NRZ, polar NRZ. In polar we have further Manchester and differential Manchester, bipolar, EMI and pseudo-natary. Now the unipolar NRZ line code. Now what is unipolar NRZ? Unipolar which having the only one polarity for the bit. NRZ is the non-return to 0. Here we are having the bit 1 or 0, right? Now 1 will be represented by plus a voltage and 0 will be represented by the 0. Only one polarity will be there, that is given the unipolar. Now unipolar is judged by the y axis, this axis only. Now here the data is 1 0 1 1 0 0 0 1 1 0 1. Here we are assigning 1 as a plus a and 0 will be represented as 0. Now again next bit is 1, next bit is 1 0 3 4 complete 0, then 1 and 1 and 0 and 1. Only one polarity will be there in the case of unipolar. Now what is NRZ? Non-return to 0. Now one bit is required, 1 bit period. 1 bit is represented by the 1 time period, that is TB, bit duration. Now for the complete bit duration it's showing having a value plus a, that is non-return to 0, right? For the whole complete bit duration means for 0 to TB it's showing a value plus a. For the next 0 to TB, when the bit is 0 it will showing a value 0 voltage, right? Now in the next slide it will be clear what is unipolar NRZ or RZ. First we must clear what is unipolar, which having one polarity only. 0 will be represented by the 0, 0 will be represented by the 0 and 1 will be represented by the plus a voltage, a variable amount of voltage. Now here you can see unipolar RZ. Unipolar RZ is return to 0 line code that has the same symbol mapping but a different pulse shape than the unipolar NRZ. Same symbol mapping means 1 is represented by the plus a, 0 will be represented by the 0 volt, but different pulse shape means here we represent plus a by TV by 2. Only for the half duration it will be showing a value of plus a. For the next 0 will be represented by the 0 voltage for the complete T. For the next TB by 2, it's showing 0 when 1 is transmitted. I will show you the example. Now see here. This is the binary data 1010. Now we have to represent the unipolar RZ line code. Unipolar line RZ code, unipolar means only plus a polarity will be there. The first bit is 1, 1 is represented by the plus a voltage. Now this is TB, this is 2 TB, 3 TB, 4 TB. Now plus a for the TB by 2 here, it will return to 0. For the next TB by 2, it will be 0. But in case of NRZ, it's showing plus a for the complete TB, non return to 0. ये क्या कर रहा है, हमारा हाई से लो के पर रिटर्न कर रहा है, रिटर्न टू 0 in this bit duration, but this will not returning, it is T. For complete TB is showing a amplitude of plus a. Now next bit is 0, 0 will be the same represented by the 0, again 1 is come, the 1 will be having a plus a for the half cycle. Now 0 will be represented by the 0. In this case you can also see 1 is represented by the half pulse, 0 is represented by the 0, 1 is represented by the half pulse, 0 and half pulse. Right. Now next come is our polar NRZ. These are the different type of line coding techniques that is used to represent our digital data. Now this data, this line coding techniques, it will use in different kind of application. For ASK, for PSK we use different kind of line coding techniques. Suppose in ASK we use unipolar NRZ, for polar we use bipolar NRZ. Now this polar NRZ, polar means is having a two polarity, plus a, minus a. Two signal element will be there, plus a, minus a. Now 1 will be represented as a plus a, 0 will be represented as a minus a. The voltage are on the both side of the time axis, plus a, minus a. Polar NRZ scheme can be implemented with two voltage, example plus V or minus V. We can take different notation, plus V or minus V. There are two versions of the NRZ, NRZ-L and NRZ-I, that is level and it is the inversion. In this NRZ-L, positive voltage for the one symbol and negative voltage for the other, whereas NRZ-I, the change or lack of change in polarity determines the value of the symbol. Example 1, symbol inverts the polarity of a, 0 does not. That will I will explain in the next slide. Now see here, in polar NRZ case, NRZ means non return to 0. Whenever the NRZ come, we will show for the complete bit duration pulse. Whenever the RZ come, we will show half duration pulse. Always remember, note it. Whenever NRZ is there, we have to represent for the complete duration. Whenever RZ is there, we have to denote with the half duration pulse. Now NRZ-L, in this case we are representing 0 as a minus plus a and 1 is represented as a minus V. So 0 is there, is the plus V, 1 is there, is the minus V. Again next is 0, plus V, minus V, minus V, and plus V. We can also interchange this polarity. 0 will be represented as a minus V, 1 is represented as a plus V, and 0 is represented as a minus V, and 1 is represented as a plus V, and again this. So here will be the data 0, 1, 0, 0, 1, 1, 1, 0. Same data is here. You can match. Right? This is known as your NRZ-L, non-return to zero level. In NRZ-L, level of the voltage determines the value of the bit. जो भी हमारा लेवल है वोल्टेज का वो डिटरमाइन करेगा बिट. सपोज वी आर टेकिंग द माइनस वोल्टेज टू 0, तो 0 बिट, 1 बिट, 0 0 1 1 1. हेयर वी आर इंटरचेंजिंग, प्लस को 0 रिप्रेजेंट कर रहा है, 1 को माइनस v, तो 0 1 0 0 माइनस हुआ तो 1 1 1 इंटरचेंज कर सकते हैं. नाउ कम्स हियर NRZ-I. व्हाट इज NRZ-I? इज inversion, non-return to zero, the inversion of the or the lack of inversion determine the value of the bit. Now see here how you will draw this NRZ-I. Here we are taking 0 will be represented as a plus V, right? Now no inversion, next bit is 0. If there is a 0, there will be no inversion. It is having a plus V voltage, it will continue the plus V voltage. If there is a 1 bit, next bit is 1, we have to do the inversion. यहाँ पे प्लस V वोल्टेज है, नेक्स्ट बिट 1 आ रही है तो हमने इन्वर्ट कर देना है. यहाँ पे स्टॉप हो गए, नेक्स्ट बिट क्या आ रही है 0, 0 पर क्या है नो इन्वर्जन, इट विल कंटिन्यू. अगेन 0, नो इन्वर्जन, इट विल कंटिन्यू. नेक्स्ट बिट इज 1 इन्वर्जन, यहाँ पे माइनस वोल्टेज है, इट विल गो अप इन्वर्जन. 1 inversion, 1 inversion, 0 no inversion. I will show you, give you an example. Suppose data is 1 0 1 0 1 0. Now 1 is represented as a plus V voltage, right? Next bit is 0. So what is the case? When the next bit is 0, no inversion. No inversion means we having a plus voltage, it will continue the same. Next bit is 1, 1 for the 1 inversion, plus V voltage है तो फिर क्या हो जाएगा माइनस. Next bit is 0, no inversion, it will continue the same. Next bit is 1 inversion, next bit is 0, no inversion, right? Now we will come to the next slide. Polar RZ. Now polar RZ is return to zero scheme. Use 3 voltage level, plus 0 minus. Each symbol has a transition in the middle, either from high to 0 or from low to 0. Now here 1 will be represented as a plus V and then return to 0. This is the RZ. It will not go to for the complete TB. It will having a voltage plus V for the TB2. Now for the 0, it's having negative for the half TB, negative voltage for the 0 bit, having a negative voltage for this half TB by 2, that is RZ, return to 0, non-return to 0. This scheme has some more signal transition and therefore requires a wider bandwidth. There is so many transition is there, so it requires more bandwidth. No DC components or baseline wandering. Self synchronization transition indicates value. Now there is no DC component as we are representing 1 as a plus voltage, 0 as a represented as a negative voltage. At last, when we calculate the DC component, whole the voltage will be cancelled out. There will be no DC component in this polar scheme. It is the advantages of polar over unipolar. Now here you can see the example. Data is over 0. 0 I have told you is represented as a negative voltage for TB by 2, and 1 is represented as a plus voltage for next TB by 2. Oh, sorry. Zero will be represented as a negative voltage and then 0 for next TB by 2, and 1 bit is represented as a plus V voltage for TB by 2 and 0 for next TB by 2. Here you can see 0 is there, negative voltage, and then return to 0. This is due to this RZ scheme, return to 0. And now again 1 is there, plus V voltage, then return to 0. 0 negative voltage, return to 0. 0 negative voltage, return to 0. 1 positive voltage, return to 0. Right? Now next is our polar, biphase Manchester and differential Manchester. Now Manchester coding is consist of combining an RZL and RZ scheme. Every symbol has a level transition in the middle. From high to low or low to high, use only two voltage levels, high to low or low to high. Here we are representing one bit will be represented as a plus A or minus A for the duration 0 to TB by 2. For the next TB by 2, it's minus A, and the 0 bit is represented as a minus A plus A. For the half bit duration, or for the next bit duration, it will be represented as a plus A. Now in this slide you can see, here we are taking 0 as high to low, means plus V and minus V. 0 is represented as a plus V and then minus V for 1 bit duration, and 1 is represented as a minus V and then plus V. This is high to low and this is low to high. So whenever 0 is come, we have to draw this kind of shape for bit duration. Now this is the bit duration, first TB, 2 TB, 3 TB, 4 TB, 5 TB, 6 TB, right? Now here 0 is represented as a plus high voltage and low voltage. Now next bit is 1. How 1 is represented by low voltage to high voltage? It will continue at this point, it will continue low to high. At this point again 0 is come, 0 is from high to low. Now again next bit is 0. So here we are having a low voltage, it will go up because the next bit is 0. this is high to low. Now again next bit is 1, it is low to high, next bit is 1, low to high, is the Manchester coding, right, is the Manchester coding. Now what is differential Manchester coding? In Manchester and differential Manchester encoding, the transition at the middle of the bit is used for the synchronization. Now what is the purpose of the having high to low, low to high? That will help us for the synchronization process. हर एक बिट ड्यूरेशन के बीच में हम यहाँ पे इंटरचेंज कर रहे हैं वोल्टेज, जिससे क्या होगा, वी अचीव द बेटर सिंक्रोनाइजेशन एज कंपेयर टू अदर. The minimum bandwidth of Manchester and differential Manchester is 2 times that of analyzed. The no DC component and no baseline wandering. None of these codes has error detections. Now in case of the differential Manchester, as you can see, 0 is represented as a low to high. Here we are taking low to high scheme for the 0, and now next bit is 1. Now for the differential Manchester we have to check the next bit. Next bit is coming 1. So if the next bit is 1, no inversion. No inversion means we are having at this point we are having a plus voltage. We will continue for this voltage, that is high to low. We will stop at this point. Now we will check the next bit. Next bit is 0. If the next bit is 0, inversion. Inversion means if we are having at minus V voltage, we have to go up to the plus V voltage. Here we are at minus V voltage, we will go up because we have to do the inversion. After this we have to check the next bit again. Next bit is 0, we have to do the inversion. We will stop at this point. Now next bit is 1. For the next bit is 1, there is no inversion. It will continue from this last point minus V voltage. Up here the next bit is again 1. We will continue from this same point plus phase voltage. So that's it for the today's session. In today's session we have done different type of line code, requirement of line code, Manchester. In the next session we will do the AMI scrambling, different type of line coding. That's it. Thank you.